Students, welcome to my YouTube channel. In this video lecture, we are going to answer questions from ILS chapter in Keith Williams Radio Navigation book. So far we have solved first 20 questions. In this video lecture, we are going to solve the next 10 questions. Where in relation to the runway is the ILS localizer transmitting aerial normally situated? So, in this diagram, you can see this runway. Now here, this aeroplane will be lining up with this runway and departing from this particular runway. That means this runway is in use. Runway, I think it's runway 22. Okay, if runway 22 is in use, so all the aeroplanes will take off from this runway number 22 and also land on this runway 22. So if runway 22 is in operation, that means the ILS localizer that is transmitting the localizer signals will be situated on the opposite end of the runway, on the opposite end of the runway somewhere here. Okay, so if this runway is in use, runway 22, so the localizer aerial will be situated on the opposite end. If runway 04 is in use that day, that means all aeroplanes are taking off from runway 04 and landing on 04. So for runway 04, the localizer will be situated here on the opposite end of runway 04. So localizer is always situated on the opposite ends of the runway. Glide slope transmitter is situated adjacent to the runway somewhere here. Okay, adjacent to the runway. So option A, at the approach end of the runway, 3 meter from touchdown on the center line. On the non-approach end of the runway, about 3 meter from the runway on the extended center line. At the non-approach end, about 150 meter to one side of the runway. At the approach end, about 150 meter to one side of the runway. So this localizer is in line with the runway. It is not situated on the left side of the runway or the right side of the runway. It is in line with the runway. So the correct answer here is this ILS localizer transmitter is situated on the non-approach end of the runway. Non-approach end means the end of the runway which is not used for approach. Now at present we are using this runway, this side of the runway, this end of the runway for departure and approaches for landing. So the localizer will be situated on the non-approach end of the runway. Okay, 3 meter from the runway on the center line, on the extended center line, means 3 meters away from the center line of the runway. 3 meters away from the runway. 3 meter, 300 meter is equal to 1000 feet. Okay, so so the localizer will be situated over there. Next, a Cat 3 ILS glide path transmitter provides reliable guidance information down to a maximum height of 200 feet above the runway, height of 100 feet above the runway, height of 50 feet above the runway, surface of the runway. So remember this, there are three operations, Cat 1, Cat 2 and Cat 3. Cat 3 has three different types, Cat 3A, B and Charlie, C. So Cat 1. The Cat 1 approach will give or provide reliable guidance down to 200 feet above the runway. Down to 200 feet above the runway. Cat 2 will provide approach or reliable guidance up to 100 feet above the runway. So Cat 2 is here 100. Now Cat 3 operations will provide reliable guidance up to the runway. Okay, directly to the runway, down to the runway. So there is no vertical limit. Okay, so Cat 3A is less than 100 feet or no decision height at all, means directly onto the runway. Cat 3B less than 50 feet, that means below the threshold of the runway, below the height of the threshold where the glide slope passes. Cat 3C no decision height, that means just remember Cat 3 operations will provide reliable guidance up to the runway, directly to the runway. Next, RVR. So you have to remember, for Cat 1, the RVR requirement is equal to 2400 feet. That is 550 meter, between 550 meter and 800 meter. So when you convert that meters into corresponding feet, it is 2400 feet. For Cat 2, the RVR requirement is 1200 feet. For Cat 3A, it is 700 feet. For Cat 3B, it is 150 feet. And for Cat 3C operations, there is no minimum RVR requirement. It can be zero visibility as well. Okay, so this diagram makes it easy to remember. Now, Cat 3 ILS glide path will transmit or provide reliable guidance information down to the surface of the runway. Option delta. Next. Which one of the following is an ILS localizer frequency? Now, ILS localizer frequencies are found in the VHF band starting from 108 MHz to 112 MHz. Between these two frequencies, all frequencies which have odd decimals, odd decimals belong to the ILS localizer. For example, 108.1, 109.3, 110.7, so on and so forth, up to 112 megahertz. Okay. Even decimals, all frequencies which have even decimals in this particular frequency band are allotted to VOR. So over here 108.25. So decimal 2 is even number. So it will not belong to ILS localizer. 109.15. So decimal 1 is an odd number. So it will belong to the ILS localizer. Decimal 2. Again, decimal 2 is what? It's an even decimal. So it won't belong to ILS localizer. It will belong to the VOR. So option Bravo is the right answer. Next. Approximate rate of descent is required to maintain a 3-degree glide path at a speed of 90 knots. So rate of descent required is equal to the ground speed of your aircraft in terms of feet per minute. So multiply this knots by 101.3 multiplied by glide slope divided by 60. So 90 knots multiplied by 101.3 into 3 degree divided by 60. So 90 into 101.3 into 3 divided by 60 is 455.8.85 feet per minute. So rate of descent is approximately 456 feet per minute. Now select that option which is closest to this value. 450 feet per minute, 400 feet per minute, 600 feet per minute, 700 feet per minute. So 450 is the closest value. So option A will be the right answer. Next, the heading rows of an HSI, horizontal situation indicator, is frozen or fixed on 200. Lined up on the ILS runway 25, the localizer needle will be what? Now, when you are lined up with the runway number 25, the heading indicator of your horizontal situation indicator should also show that runway heading, which is runway 25, runway 250, whatever. But in this case, this heading rows is fixed at 200. So will it affect localizer readings? So the correct answer is delta. Okay, so remember, this is your horizontal situation indicator. Now the localizer indications are independent of your horizontal situation indicator heading. Okay, they are independent of the heading. So that's why when you are lined up with the runway for takeoff, the localizer needle, the CDI needle, this CDI needle will remain in the center. It will align with the center. Next, what is measured in order to establish aircraft position in relation to the localizer beam on an ILS? The difference in depth modulation between 90 Hz and 150 Hz modulations, the difference in time between 90 Hz and 150 Hz modulations, the bearing of the localizer antenna found by means of a loop antenna, the difference in phase between 90 Hz and 150 Hz. So, your localizer transmitter, which is located on the opposite end of the runway, on the non-approach end of the runway, will transmit in the VHF band between 108 MHz to 112 MHz odd decimal frequencies. Okay, so these main frequencies are further amplitude modulated. 90 Hz signal and 150 hertz signal. Okay, so now when you come down for landing, you must be established on the extended center line of the runway. This is the center line of the runway. Extended center line is nothing but an imaginary center line in the atmosphere. In the atmosphere. So you are expected to be positioned on this center line and follow this center line down to the runway, because you are required to land on the center line of the runway. So you have to begin that process right from the beginning in the atmosphere. So you have to continuously track this center line, extended center line of the runway. Now, when you are tracking this extended center line of the runway, when you are correctly positioned on the center line of the runway, your system, your ILS equipment on board will receive this 90 hertz signal and 150 hertz signal equally. Okay, the system will receive both the signals, amplitude modulated signals equally. We call this principal difference in depth modulation. Okay, so when it is on the center line, it receives both the signals equally of equal depth. If this aircraft deviates to the left of the center line somewhere here, let's say, okay, now it's to the left of the center line, that means it will receive more of 90 hertz signal and less 150 hertz signal. Why? Because it is to the left of the center line where 90 hertz modulated signal is predominant. Okay, so in that case, the CDI needle will tell you to fly right hand side. Why right hand side? Because the runway center line is to your right. So you will have to fly right, capture it, and then fly along that center line. Let's say you deviate to the right hand side of the center line. Okay, when you deviate to the right hand side, you will receive more of 150 hertz signal and less 90 hertz signal, because you are in the 150 hertz signal area. Okay, so in that case, the CDI indication will tell you to fly left, because that's where the runway center line is situated. So you will fly left, capture that center line, and fly straight ahead along the center line of the runway. So remember, the principle is called difference in depth modulation between 90 hertz signal and 150 hertz signal. So option alpha is the right one. Next. Okay, over here. So when you are right on the center line of the runway, extended center line, you receive 90 hertz signal, 150 hertz signal equally. So they have painted this aircraft orange, half blue. When you are to the left of the center line, you will only and only receive 90 hertz signal. So they have painted this aircraft orange in color. So in that case, the CDI needle will tell you to fly right hand side. You can see this needle has moved to the right hand side with respect to the pilot inside this aircraft. Okay. Over here, when it is on the center line, the needle is on the center line. When aircraft deviates to the right hand side, it receives more of 150 hertz signal, so they have painted it blue in color, and the CDI needle tells the pilot to fly left hand side. Therefore, the CDI needle has gone to the left. So pilot will have to turn left, capture the center line, and fly straight ahead. Okay, so this is the principle of operation. Next, what are the modulating frequencies of two overlapping lobes that are used on an ILS approach? So the modulation frequencies are 90 hertz and 150 hertz. Okay, so just 90 hertz, 150 hertz for localizer. Similarly, for glide slope, you have 90 hertz signal and 150 hertz signal. Next, full scale deflection of the localizer needle indicates aircraft is approximately 2.5 degrees offset, means deviated from the localizer center line, 10 degrees offset from the localizer center line, 1.25 degrees offset from the localizer center line, 5-degree offset from the localizer center line. So remember this. You will have to remember this picture. Look at the localizer column. Now if your CDI indicator is a 4 dot indicator like this, it's a 4 dot indicator like this. So in this case, one 4 dot indicator. So in case of 4 dot indicator, every dot is equal to 0.625 degree. If it's a 5 dot indicator, every dot will be a value of 0.5 degree. Now, either way, if you are using an indicator which is 4 dot or 5 dot, the maximum deviation expected or provided is equal to plus minus 2.5 degree. Plus means right hand side, minus means left hand side. Okay, so for localizer, the maximum deviation possible is 2.5 degree to the right of the center line or 2.5 degree to the left of the center line. For glide slope, maximum deviation is zero point 0.7 degree, even more sensitive than localizer. So the correct answer is option A, 2.5 degrees offset for the localizer center line. In case of VOR, it is 10-degree offset from the VOR radial center line. Okay, in case of ILS localizer, it is 2.5 degree maximum deviation. In case of VOR radials, it is 10 degree. Okay, so remember this. Next. On an ILS approach, the localizer needle is fully over to the left hand side. That means this this localizer needle has fully deviated to the left hand side to its maximum limit. Okay, to its maximum limit to the left hand side like this. What does that mean? So, how much deviation does this indicate? So, when it is fully over to the left, what is the fully over to the left means maximum deviation has happened to the left hand side. So just now we saw maximum deviation in case of localizer is equal to 2.5 degrees. So option alpha is the right answer. Next. False beams on ILS glide path are found below the correct glide slope, found if more than 10 degrees left or right of the localizer center line, found if lying back course of ILS, only found above the correct glide slope. So remember, okay, your glide slope transmitter will transmit the standard 3-degree glide slope. Okay, it will transmit this standard 3-degree glide slope where the aircraft is situated. Now, because of ground reflections, this glide slope signals can be regenerated above this standard glide slope. Okay, so that is one advantage, that the false glide slope signals that are generated are found above the glide slope. Okay, so that is one advantage, they are found above the glide slope. So, in case your aircraft mistakenly follows that false glide slope signal, it will at least be away from the ground at much higher level. So you can see these are the three false signals that they have drawn. Okay. Now let's say your aircraft is following this correct glide slope down to the runway, but all of a sudden, if it comes in contact with false glide slope signal, which is little bit above this standard correct glide slope, the autopilot of your aircraft will automatically start pitching up, like they have shown here, in order to capture that false glide slope. Okay, so it's a very grave mistake. So this is one thing they can ask you in Viva. How do you come to know whether you are flying the correct glide slope or the false glide slope? Okay, so this is your false glide slope, which are result of or which are caused by ground reflections. And the second point, very important point, is that these false glide slopes are only and only found above the correct glide slope. Okay, so the correct answer here is option delta. Only and only found above the correct glide slope. That's it. So we will stop here. I will do the next 10 questions in the next video lecture. I hope you have understood all the 10 questions I have answered in this video lecture. If you have any doubts or questions, let me know in the comment box.